Just the signs get confusing.
Yeah, the signs are the tricky part, aren't they?
It got me in the beginning, like, as soon as you mess up one, you're going to
You're right. You're right. It's all about those signs. Being careful with those signs, right? And that's why I did the whole thing. Remember, whatever sign's in front of something, that goes with that item, wherever it may go. Right on that. Okay. So let's. All right. So 4.7. This will be an easier section. 4.8 and 5.1 will be a little harder. So I'm going to go quick through this one. Slow down for the other two. All right, so 4.7, they basically want me to take that polynomial, x squared minus y squared plus xy, and they want me to plug into it, x is 2, y is negative 9. Just a plug in. Remember when you plug into formulas, or polynomials or whatever, you put parentheses around the numbers you're plugging in there, right? So I'm going to plug the 2 in for x there, and the negative 9 in for y there and there, huh? Make sense? So it'd be 2 squared, and y is negative 9 squared, and x is 2, y is negative 9. Is that good? See all those little parts plugged in with parentheses? Is that all good? Good. So I just plugged in the x is 2 everywhere I had x with parentheses around it, and the y is negative 9 everywhere I've got y with parentheses around it. 2 squared is 4, minus negative 9 squared is regular 81. By the way, notice I remove the parentheses when I do squaring or multiplying or whatever. Once the parentheses do their thing, then they're gone. Right? Well, it is. But this one in front here is still there. This one has gone away to be plus 81. Does that make sense? Well, yeah, because this right here means, maybe it'd be more helpful if I went a little slower. What if I write it like this? Doesn't that minus 9 mean minus 9 minus 9? But that's different than this subtraction symbol, which is still just sitting here in the front waiting for the minus 9 thing to finish. So that's regular positive 81. Does that make sense? But it's going to be minus in the end because of that other minus. Everybody see that? Yeah, so the minus that's in the parentheses vanishes because of the squaring. But the other minus in the front still stays there. Good? Yeah, signs are an important part of all this. Now, what about 2 times negative 9?
Negative 18.
Negative 18. A positive times a negative is negative, huh? All right. So in the end, then, you don't need this little plus on the 81. So it's 4 minus 81 minus 18. You know, plus a negative 18, that's just minus 18. If it bugs you, you can just write minus 18 if you want. Yeah, if you prefer it that way. It's whatever, yeah, it's just whatever sign's in the front. So just do that. You use your calculator. 4 minus 81 minus 18. 18, is it minus something like 95?
Yes.
Minus 95. Is that good? Questions on that? All right, let's keep moving. Okay, so x squared minus 3y squared plus 2xy. So x is 8 and y is negative 3. So plug those in. Plug in for x everywhere an 8, parentheses around it. And y everywhere negative 3, parentheses around it. And then just work out the numbers. Feel free to compare with those around, just see if you're getting the same answer. good. 64 minus 3 times 9. See how I'm doing that? Is that making sense? So I just plug in the 8, the minus 3, the 8, the minus 3, the x is a y. And I start working it out. 8 squared is 64. Means 8 times 8. Use your calculator if you're rusty on some of those old times tables. And then negative 3 squared, that minus is going to vanish because it's squared, right? 2 minuses. Makes it plus 9. 3 times 3 is 9. And then over here, I just multiply these with my calculator. 2 times 8 times 3. I know it's going to come out negative because I have one negative sign, huh? Remember, if there's 2 negatives multiplied, that's positive, but 1 negative multiplied is just negative, huh? So I know this string of numbers, the 2, 8, negative 3, is going to come out negative. So I just write down the negative sign, and then I just multiply 2 times 8 times 3 on my calculator, and it's 48. So keep going. 27 in the middle. And then just hit the buttons on your calculator. Is it minus 11?
Yeah.
Minus 11. Is that good? Questions on that? All right. I think it's just a plug-in. Let's see. So it's talking about this rocket landing and da-da-da-da-da. It gives me this formula right there. H plus VT minus 4.9 T squared. So basically, our job is to try to find the plug-ins. Let's see. 80 meters high. I'm just going to look for the numbers. Blah, 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 blah. Just grab numbers. 80 meters high. Which letter is that? H. That's my H. Huh? So put 80 right in there. Next. Upward speed of 80. What do you think speed is? V for velocity. Huh? Put that in the velocity. What was it? Oh, it's 80 also? Yeah, that's funny. They're both 80. 2 seconds. What's that? Time. That's T. So you see how it's just a plug-in. You don't need to read all those words. Just grab the numbers and plug them in the appropriate slots. It's not a real word problem. It's just a plug-in. Then just hit the buttons on your calculator. So this will be 80. This will be 160. This will be, what's that times 4? 2 squared is 4. And then, I don't know what, 4.9, 196. Is it 19.6?
Yeah.
Back there, 19.6. See what I'm doing there? I just multiply the numbers in the middle. And then 2 squared is 4, and I multiply these. Like that. Good. And then now just use your calculator, add them, subtract them and stuff. 240 minus 20 would be 220. Is it 220.4?
Yeah.
220.4. There it is. Is that good? So it's not a real word problem, it's just a plug-in. Find the numbers and plug them in. All right, I'm going to keep moving. Okay, so they want me to basically subtract these things. So it's xy minus ab minus 6, take away xy minus 5ab minus 3. Okay, so what do I do first on this problem? You all know? What do I do? Yeah, that negative in the middle, huh? That negative in the very middle has to distribute to everything to the right, huh? That minus needs to go boom, boom, boom. Now remember what I was saying about, any sign in front of somebody, that's their baby, that's theirs, right? So let me even rewrite it that way to make it extra clear. Meaning this minus is really on the 5, this minus is really on the 3, right? And, whoops, that was a mistake. This minus is on the 6, this minus is on this parenthesis. That's why he goes through the parenthesis on his right, not the one on his left. So everybody good with that? Any sign in front of somebody, that's their baby, right? That's going with them wherever they may go. So distribute that through. So we get minus xy, minus times minus is plus 5ab, and minus times minus 3 is plus 3. Does that make sense on that? Now, is there anything over here in the front of the first parenthesis? Anything over there, over here, in the front of the first parenthesis? Nothing. So there's nothing that's going to distribute through. So just drop the parentheses. Nothing happening there. Doesn't matter at all. Make sense on that? But there was a minus sign in front of the second parenthesis, which distributed all the way through. Okay, I've dropped the parentheses. Hey, by the way, let me stop for a second. Why did these parentheses not mean multiply? If I was sitting in your seat, I'd probably be thinking, wait a minute, I thought parentheses, we just did a bunch of parentheses. The quiz today was parentheses and we multiplied. Why aren't I like foiling, like why didn't I take the xy? Why didn't I take the xy and say boom, 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 and then, why didn't I do all that? Because of the minus in the middle. When do parentheses mean multiply? When they're right up against a nothing in the middle, huh? So if this minus wasn't here, and these guys were right up against each other, then that would be like the quiz one we did today, where they got to take turns, and they got to go to everybody, everybody, everybody. But if there's a sign in the middle, then it's not multiplying, right? It's adding, subtracting. After you distribute the negative, then it's adding, subtracting, huh? Making sense on that? So parentheses only mean multiply when they're right up against each other. Good. All right, so now we just do like terms, right? And so what are the like terms here? xy and minus xy just drop out, huh? What now? Minus ab and 5. We're doing like terms, same letter patterns with same letter patterns. What do you do with minus ab and plus 5ab? The numbers in the front, huh? What's in front of this one? Minus 1. So 5, take away 1, 4, AB. And you don't mess with AB. You don't make it a squared, b squared. Or no messing with powers when you're adding, subtracting. That's only when you're multiplying that powers add, right? All right, and then minus 6 plus 3. And we're done.
Wait, why is it positive?
Which one?
The 4AB.
Yeah, because it's plus 5 and minus 1. So think real life money or football. If you've made $5 and lost $1, where are you at? You're up 4. You're positive 4, aren't you? Or the football team gains 5 yards and loses, well, I guess football season's over. But gains 5, loses 1. They gained 4, right? So just think gains and losses. Now I know you might think, wait, Miss Tarrant, you said 1 negative is negative. That's multiplying, dividing. So you have to solid separate those in your mind. The 2 negatives make positive, 1 negative is just negative. That's multiplying, dividing, not adding, subtracting. Yes, let me write. Is everybody clear on that? So when you say 2 negatives make positive, 1 negative's just negative, that's when you're multiplying, dividing. That's not here. That's not with these two. These are not multiplied, divided. This is add, subtract. What's the rule when you add, subtract then? If it's not 2 negatives make positive, like I said, it's money or football. In other words, it's gains and losses, right? You gain or lose money. Right? You gain or lose ground in a football game, right? It's gain. So for add, subtract, just think gains and losses, right? I gained $5 and I lost $1. I gained 4. Football team gained 5 yards, lost 1. They gained 4. Plus 4, regular 4, right? Don't think 2 negatives make a positive or 1 negative is negative. That's all multiplying, dividing type thinking. You got to separate those in your mind. Good. All right. Okay, let's try that one. So a to the 7th plus bc, a to the 7th minus bc. So how do we know that's multiply? I mean, other than the fact that they said the word multiply.
Nothing in the middle.
There's no symbol in the middle. The parentheses are right up against each other, so that always means multiply. Yeah. So go ahead, that's going to be the taking turns kind of thing. And when you multiply, powers add, don't they? That's where the powers add. Boom, boom, right? Powers on same letters, I mean. Powers on matching letters add. So a to the 7th, what's that going to be? 14, huh? Those powers add when we multiply, right? Minus a to the 7th BC. He's done. Good so far? Okay. Now it's the BC's turn. He's going to go to both, right? So plus a to the 7th BC. You can write it BC and put the a to the 7th at the back. The order doesn't really matter. Any order is fine. Plus, or minus, right? Because positive times negative, those are their signs in front of them. Those are their babies. Positive times negative is negative. What's going to happen with BC times BC? Powers on matching letters adds B1, C1, B1, C1. So B1, B1, B2. C1, C1, C2. Because we're multiplying. When you multiply, powers add on matching letters.
So you wouldn't cancel them, only on addition and subtraction?
Right. Only cancel on adding, subtracting. Exactly. Well said. Exactly. So these will now cancel, won't they? Right? That makes sense.
How did BC cancel up there in the parentheses? And you're canceling ABC down there.
Yeah, because right here, so let me ask you this. Let me answer your question with a question that I think will be helpful. If I said, what is 5 times negative 5? Would we say 0? Would they cancel and it's just 0? And if somebody said 0, you would say to them, you're crazy. It's not 0. You're multiplying. Right? So it's negative 25. They're only 0 when you add or subtract them. Right? That's it up here. Right here, I'm multiplying them. So that's why they don't cancel out. Does that make sense? I'm timesing them. So I think the main issue in all these problems, I think for everybody, is really being clear, am I in multiplying mode right now, and thinking multiplying thoughts? Or am I in adding, subtracting mode right now, and thinking adding, subtracting rules and thoughts? So you want to be clear on that, right? So up here, when there's still parentheses, I'm multiplying. Yeah, powers are adding, and I'm multiplying, and 2 negatives make positive, and all those multiplying rules. Down here, once the parentheses are gone, I put on my adding, subtracting thinking rules. And that's where the canceling can happen. Good questions. Is that making sense? So there's our final answer. So many rules, huh? There's just a lot of rules in algebra. It's just, you know, it's like learning Chinese. It's a language. It's very, very similar to a language, right? Yeah. Car. Yes, I'm learning names slowly here.
The negative b in front of, or the negative in front of the b squared. What does a negative, when you're multiplying, do to the c squared?
Oh, nothing. They're a package deal. Okay. So, yeah. So the plus is for the whole BC, and the minus is for the whole other BC. Okay. And so the signs just do their thing in front of the terms. They don't do anything, beyond that.
I didn't know if it would be significant or not.
Yeah, just that plus and that minus are just on the whole BC and the whole BC. So it's just positive times negative is negative, the whole b squared, c squared. Okay, so 4m squared minus 7n squared, 2m plus 5n. All right, so is that one a add, subtract, or multiply? Well, because the parentheses are right up against each other, it's multiply. So your first thoughts are all multiply thoughts, which means nothing cancels, powers add. right, so we distribute. So again, we're in multiply mode. So out front numbers multiply, powers add, right? Out front numbers multiply, powers add. So 4m squared times 2m. Out front, 4 times 2 is 8. Powers m2, m1 makes m3. Good for the first one. Plus 4 times 5 is 20. M squared n. The 4m squared is done. So I'm halfway there. Is that making sense so far? What you guys are getting? Now, the minus, and that minus is on the 7. It's going to go with him. It's his baby. Wherever he may go, that minus is going to go with him, right? So minus 7n squared times 2m is minus 14m n squared. Is that good? Out front numbers multiply. And then minus 7 times plus 5, minus 7n squared times plus 5n is minus 35 n cubed, right? Because the n2, n1 powers add. We good to there? Oh yeah, it's off the screen. The screen's really off today. All right, so we good to there now? Now, are there any like terms? Because multiplying's over now, by the way, right? Multiplying is over. How do I know? There's no more parentheses. Parentheses are gone. I'm in adding, subtracting mode. So I put on a new way of thinking. Adding, subtracting, I'm just looking for like terms, same letter patterns. And I just do the numbers in the front. Don't mess with powers. Are there any same letter patterns?
Only mn squared and 14mn squared.
They're a little different. See, the square's on the m, and over here it's on the n. So the letter pattern is slightly different, so we're done. There's nothing more we can do. That's just it right there. There's no like terms. Nothing can combine further. It's got to be exactly the same letter patterns to add them and subtract them.
That will be your answer.
That's our answer. Is that good? Questions on that? Yeah.
So I got exactly what you did. However, can you explain to me how it's 14m squared and not how it's not on the? Because at first I put 14m squared and m, so I reversed.
Oh, you put 14n squared and m?
Right, and then I looked at it again. I said, oh wait, it's both of them. But can you
That's what I
explain to
did.
me how it's kind of not like the 20m?
You mean in this spot you put that?
Right. But
That's
then-
totally fine.
Okay.
Those are the same and both are right and good.
Does it work?
Yeah, so the order in which you write the letters doesn't matter at all. As long as you got the 2 on the end and the m is regular, either order is fine.
Can you see if it'll enter in that way though?
It will. I've done it,
Oh, okay.
maybe not 100 times, but I've done it a lot. It does. Math is simultaneous.
So then wouldn't the 20m squared m be the same thing?
No. Yeah, good question. So you might look at this and go, well, now they're the same. No. The 2 is, look at them. Are they the same? The 2 is still on the m, not on the n. They're still not the same. So the order doesn't matter. It's where the powers are that matter. The 2's on the m. Here the 2's on the n.
Right.
Different. I don't care about the order.
Okay.
It's just the 2 is on a different letter.
Yes.
Yeah. Makes sense? Good. Other questions? So yeah, either way you want to write. The order in the letters doesn't matter at all. All right. All right. So 4x plus 3h with a 2 power up there. So what's that going to do? Yeah, do you realize we have to actually write 2 of them? Does that make sense? You have to actually go like this. You know what I mean? And then it's just a normal FOIL again. So go ahead, take it from there. You have to actually write 2 of them and then FOIL. So take it from there. So this 4x goes to both. And what happens? We're in multiplying mode now, right? So put on our multiplying thinking, which means out front numbers multiplied, powers add. Powers add. So 4x1 is 16x to the 2 power. Is that good? Plus, and then 4x times 3h is 12. xh, or you could write hx, the order on the letters doesn't matter. That 4x is done, he's had his turn. And now the 3h will go to both. 12xh, or 12hx, doesn't matter. Plus 9h squared, right? Because the 1 powers on the h's add. Everybody good to there? Now, multiplying's over, huh? The parentheses are gone. We're done with the multiplying, and we change modes, change gears, we shift the car. So now we're in adding, subtracting mode. Different set of rules, right? Only like terms, only same letter patterns can be combined. Are there any exact same letter patterns? And letter patterns mean not the numbers in the front. We don't care about that, but we care about powers. Those two are the same. They're both XH, right? They're both, and they don't have any different powers or anything. They're exactly the same. So they're like, we combine them, right? Whereas the 16x squared, he's just going to come down, nothing there. The 9h squared, he just comes down, nothing there. But the two middle, the 12xh and the 12xh, they combine, what do they make? 24. Now, is it x squared, h squared? It's just xh. We don't make squares. We're not, because we're not multiplying. We're adding. We only add the numbers in the front. You don't mess with the powers, right? Remember the rules in adding, subtracting mode? You don't mess with the powers. And that's it. These rules starting to make sense? You speaking Chinese a little bit? That's why it takes practice, because it's like learning Chinese. You gotta practice it. All right. All right, so we have 7x, x minus 7y squared. Now, this is a tricky one. Let me give you some assistance on this one. What do we always do with the 2 power? Going to write 2 of them, huh? When a 2 is on a parenthesis, that means you write 2 of them. Like that. Okay, now, the trick on this one is we have like a 7x in front that wants to multiply and a couple parentheses. Really, there's different things you could do here. I found it's easiest for students typically to just go ahead and multiply the parentheses first. So I'm just gonna let the 7x sit in the front and just ignore it for a little bit. He'll have his turn in a bit. But first off, I'm just gonna do the thing we always do with the parentheses, you know, and just multiply them. So do that. Go ahead and do that first. Just let that 7x in the front sit there. His turn will be at the end.
Do we combine?
Yeah, combine as well. Good. Is that good so far? So I took that x and I multiplied both terms. He's done. And now I'm going to take the minus 7y, and I'll get minus 7xy plus 49y squared. Is that okay? 2 negatives make positive. We're multiplying, so 2 negatives make positive, right? Negative 7 times negative 7 is plus 49. Y squared, the 1 powers on the y's, add to be y squared. Good so far? Now, these two in the middle we can combine, huh? Those are like terms. You could do that now, or you could distribute the 7x first and do it later. It doesn't matter. It'll work either way. But I'll just go ahead and do it now. So what is minus 7xy and minus 7xy? Negative 14. Am I multiplying those right now? No. So I don't mess with the powers. It just stays xy, huh? You just do the numbers in the front. If you lose $7 and lose $7, you lost $14. Right? Minus 7, minus 7. We good to there so far? So I finished up the multiplying the parentheses. Now the 7x has been patiently waiting for his turn. Now is his turn. Now he'll distribute through. So now the 7x goes boom, boom, boom. Right? So I just saved him for last. So go ahead and distribute him through. So 7x, we're multiplying right now, right? It's multiplying. So that means out front numbers multiply, powers add. 7x1 times x2 is 7x3. Good. 7 times 14, what's that, 70, 98? X squared y, because the 1 powers on the x's add. That good? Plus 7 times 49, is that 343? Yeah. 343 x y squared. I've solved this very problem like probably 50 times. So I've kind of got it memorized after a while. Is that making sense? There, and we're done. We can't go any further because the letter patterns don't match.
So all these numbers for them, when you finish the
Multiplying.
multiplication?
What was your question?
Always when you finish the 7,
Yeah.
when you finish all of them.
Oh yes, I save this till the end. So I finish all the other. Yes, exactly. That's when you have three things, do the parentheses first. Save the front until the end. Yes, exactly. Exactly. Yeah, that's the point of the problem. Everybody seeing what I'm saying? If you have three things, just do the parentheses first, save whatever's in the front, do that last. Okay, good. All right, so 35 x to the 6 over 5. So now we're dividing. We've been multiplying for a long time. Now we're going to divide some stuff. So I think this first one you probably know right off the top of your head. What do you do when you're dividing? Just divide, huh? Just divide those numbers. Nothing magical there. It's just 7, huh? And 5 goes into 35 7 times. Use your calculator if you're rusty on some of those. Just 7x to the 6. Nothing more. There we start out easy, huh? Then they get messy. Okay, so 184 r to the 13th over minus 8 r to the 11th. Okay, so I would start with my calculator. I don't know what 184 divided by 8 is. 23? Thank you. And yeah, and when it's 23. And is it positive or is it negative? Yeah, it's negative. Do you guys know why it's negative? Because it's one positive and one negative. Remember, multiplying, dividing. 2 negatives is positive, 1 negative is just negative. Right? For multiplying, dividing, and I am dividing. Is that good so far? So just divide those. Now, so you divide the numbers in the front. We did that. What do you do now with these powers?
Subtract.
Yeah, subtract. It's just going to be 2, huh? 13 minus 11 is 2. Very good. Hey, by the way, what if the bigger power was on the bottom instead of on the top? Then the leftover 2 would be on the bottom, wouldn't it? Wherever the bigger one is, that's where the leftovers go. We had the bigger one on the top, so it's just top. It's just regular. Good on that? Remember all those rules? Did some of that earlier. Okay, good. Okay, so 24x to the 5th plus 54 x to the fourth minus 42x squared all over 6x squared. Yeah. So basically, you know what we do on this one is we just make 3 division problems. It's just that because it's one big bar, right? So they're all over that 6x squared, so they're all going to divide. You don't have to write 3 separate. If it helps you, go ahead. If you don't want to, don't bother with it. I'm just going to write, I'm going to do it because I think it's more clear, but you don't need to. So I'm just going to write 3 separate divisions because that's what it really means. Just 3 separate divisions. By the way, that's the same thing as, it's like distribution. You know, what if I had the 6x squared in the front with parentheses? What would I do? I would let it go to all 3, wouldn't I? Yeah. Well, that's kind of what I'm doing with dividing, right? I don't have any parentheses, and I don't have it multiplied. I have the thing divided, but in the same way I distribute it, divide it by all 3, don't I? It's the same thing. It's just dividing distribution, like multiplying distribution. You know, it just goes to all 3, divides all 3. All right, now you know how to divide, huh? So how do we do this first one?
4x cubed.
Yeah, you divide the numbers, and you can just calculate 24 divided by 6, or if you happen to remember, it's 4. 6 goes into 24 4 times. You divide the numbers, and what do you do with the powers? Subtract them. X to the third. That good? Next one. Divide the numbers. Anybody know 54 divided by 6?
9x cubed.
9. And what do you do with the powers? Subtract them. 42 divided by 6, 7, and you subtract the powers.
So there's 7. Cancel out.
It turns out it's just 7. There's no x at all. But a common mistake I see a lot is people will write x with no power at all, and they think they're doing a 0 power when they do that, but that's not right. If you just write x with no power at all, yeah, remember there's always an invisible 1, not a 0. And that's not right. We can't have x to the 1. 2 minus 2 is not 1. So that's why there's actually no x at all. The 0 means nothing's there, huh? It's just 7, no x at all. And there's our answer. Good?
And we don't combine.
Well, we would if we could, but we can't, so we don't. Yeah, because none of them are like. Yeah, none of these are like terms, huh? So we can't combine them. Good question. Always be looking for that. That's good. So 3 separate divisions. 36 divided by 9 is 4. Subtract the powers. What's the power on the bottom? 1, so that's x to the 6. We good? Minus 45 divided by 9 is what? 5. 3 minus 1 is 2. 36 over 9 is 4. X is completely drop out. There we go. Does that make sense there?
Yeah.
On the test we take in a couple of weeks, you know, one of the multiple choice options, they try to fool you. The publisher, you know, I really mean they. You might think it's you, mister. It's not. I'm just grabbing the questions off the publisher's test bank thing. The people that make the book, they put out these tests. Anyway, and they always will put one of the options, like option C or something, and they'll put an X there at the end. So, right, you won't be fooled by that, right? There's supposed to be no X at all at the back. The X's have dropped off completely, right? So don't bite when they bait that hook. We good? That make sense? All right. The next problem in this section is super hard and very difficult, and so are all the rest. What number are we on? 6 out of 15. So the last 9 are crazy hard, and I don't want to do them.
So you just do the answer?
A little bit. Yeah, here's the deal. They're super hard, and they're super unimportant. Seems funny for me to say as a math teacher, but really they're not. I'll put one of them on the test. It will never come up again in the rest of the course. I won't even put one on the final of the next stuff we're about to do. And you'll never see it again in the next class or any other math class you ever take. Yet, it's super, super hard. And we could spend an hour and you would still be saying, I don't know, Miss Taryn, because it's messy and ugly. That would not be a good use of our time. So what I'm going to do is I'm going to skip it for now, jump ahead to 5.1. do a good job with you on 5-1. And whatever time we have left, I'll jump back and throw you a little bit of time on that other stuff. But if you want to ignore it, it's just one question on the test. It's 4 points. I give you a bonus 5 points anyway. You can get 100% without even learning it. It's just not important. I want to spend our time on what really matters. The 5.1 is super important for the rest of this course. So I want to go there and do a good job on that, and I'll jump back here with whatever time we have left. It won't, it won't. All right, to 5.1 we go. Like I said, we'll go back if we have time. We'll go back for a few minutes at least. But you won't be satisfied when I go back. It'll get ugly and almost go, yeah, that's all the time we got. But you can blow it off if you want. Still get 100% of the test. All right, so this, though, is super important. Let's do a good, slow, careful job on this. I want you all to get 5.1 really, really well. Because what we're doing now, Chapter 5, this is probably the most important, this is the most important chapter. Because you'll use this factoring throughout the rest of this course, the next course, any course in math. Tons of factoring. Super important. So we want to really learn this well. I want to make sure we spend some good, slow, careful time here. So x squared minus 4x. They want us to factor the whole rest of the chapter. Chapter 5 is going to keep using that word factor. Factor, factor, factor. So first off, what does factor even mean? What do they mean, factor? They mean unmultiplied. To factor means find what it was before it was multiplied. Yeah, it's going to be one parenthesis, it turns out. I'll explain. But that's the first time I wanted you to have the basic idea. Because they're going to be saying that word forever. Let's be clear what that word is. Factor means find what it was before it was multiplied. Now, what they're saying is hey, look, there was something outside of a parenthesis. And there was like two things in a parenthesis, and we distributed, and it became this x squared minus 4x thing. What was it? What was it that we multiplied and became this x squared minus 4x thing? That's what they want us to do. They want us to unmultiply, if you will. That's what factor really means. Find what it was before it was multiplied. Okay, so how do you do that? First off, how do you find the thing that's outside the parentheses? You're right. How'd you know? Yeah, if you look at these two terms, notice they both have an x. That's what it is. You put it on the outside since they both have it in common. Now, it should be minus in the middle, shouldn't it? Not plus. All right, now, how do you know what goes in the middle? In the two slots on the inside. Yeah, you just ask yourself, whatever works. What would work? What would multiply to go back correctly? In other words, x times what will go back to x squared? Just plain old x, because the 1 powers would add, huh? And x times what in the second spot would go back to the 4x? Well, just a 4. And that's our answer. That's it. That's what would multiply, that's what would distribute to go back and become x squared minus 4x. We basically unmultiplied it, right? We found what it was before it was multiplied. That's called factoring. Super important in higher math and all kinds of real life applications when they do things in the real world with math. Good for that first one? All right. All right, so 4x squared plus 36x. Again, they're going to say factor. That's pretty much what they're going to say for the whole chapter. Factor. So what does that mean? That means one parenthesis, find what goes in the front, two things on the inside with a plus. Find what it was that was distributed that became 4x squared plus 36x. All right, so how do I do that? It's all about finding this outside thing first, right? Now, let's talk about the numbers and the letters separately. How do you know what number goes there first off? You look at the 4 and you look at the 36 and you ask yourself, what is the greatest number that divides evenly into 4 and 36. And just use your calculator. Or maybe you know it already. If you're rusty on some of these time tables, use your calculator. What number goes into 4 and 36? What number could you divide them both by? It would come out clean. 4, huh? 4 goes into 4, and 4 goes into 36. Now, there's other numbers, but 4 is the greatest one. 2 goes into both those, right? 2 goes into 4 and 36 evenly, cleanly. But the greatest number, so does 1. 1 goes into everything. 1, 2, and 4 go into both 4 and 36. So the greatest number that goes into both those is 4. You with me on that? So 4. Now we also need some x kind of stuff too. But so far good on the number. So the number, you just take the biggest or greatest number. It's called the GCF. It means greatest. Yeah, greatest. You already know it, huh? Common factor. Greatest common factor. Anyway, I'm not going to quiz you on the names, but anyway. So the greatest number. Okay, now what do you do with the letters? How do you know, like, what letter? Yeah. For the letters, let me give you the rule. You take the smallest power, which seems weird. So you look at x squared and x to the first. Which one's smaller? Well, x to the first, or regular x if you want. You don't need to put that 1 there. That's what you always do. You always take the smallest. Now, why? I thought you said we're doing the GCF. We are. That's the same thing. The greatest common factor is the smallest. Now, it sounds like I'm a politician when I say that, huh? We're going to give you money, and we're taking it away. You know, I'm just talking out 2 sides of my mouth. But no, I'm not a politician. I'm a math teacher, so I speak truth. That is the truth, actually. The greatest amount in common is the smallest. Let me prove it to you. What if you had one friend that had 3 x's? I don't know if you have friends that have x's. Another friend that had 2 x's. And you said, all right, friends, what do you have in common? Do you both have at least 1 x? They'd go, yeah, we both got at least 1 in common. Do you both have at least 2? Yeah. All right. You both got at least 3. No. So what was the greatest amount you both had? 2. The lower. See, the lower is the most in common. It's true. Doesn't sound true at first, but it is true. So it's the same thing. You take the lower powers. All right. So now, let's just figure out what works. Once you got that outside, the rest is pretty easy. Just whatever works, you know. 4x times what would go back to 4x squared? Remember?
X.
Yeah, x to the 1 because the powers add, right? Yeah. And then 4x times what would go back to 36x? 9, because 4 times 9 is 36. Use your calculator if you're rusty on those. That's it. Good on that. We're finding what would multiply. That's factoring. Just taking it apart, kind of. Breaking it into those pieces becomes very useful later. We'll see. All right. Is that on the screen? Yeah, okay. So 9x to the 5th minus 45x to the 3rd. Same kind of thing. That magic word, factor. So parentheses, something in the front. 2 things on the inside with a minus. The thing that goes in the front is called the GCF. All right, so what goes into 9 and 45? 9. Use your calculator if you're not sure on that, if you're rusty on some of those. 9 does. Okay, now what power on the x am I going to put in front? The lower one. Remember, you look at the 2 powers, and you always grab the lower one because that's the most they have in common. They both have 3 x's or more. It's the most they have in common. Good? Good for the GCF, the greatest amount in common. We just took the greatest amount they have in common. The greatest number they have in common is 9. The greatest amount of x's they have in common is 3. So we took all their commonness to the front. And now, what goes on the inside? Whatever works. 9x cubed times what would go back to 9x to the 5th?
X squared.
X squared, because the powers would add, huh? And Now for the last one, 9x cubed times what would go back to 45x cubed?
It's minus 5.
Yeah, the minus 5. Again, if you're rusty, just use calculator. And that's it. Does that make sense? So you always take out the number that goes into both and the lower of the two powers for the GCF. No questions? We good? Keep going. Okay, so 7x squared plus 7x minus 28. So it's the same game, it's just 3 of them. So just put a big old parenthesis, put something in the front there, and there's going to be 3 things on the inside with a plus and a minus, between them. Just the same exact thing. Just find what number goes into all 3 of those. What number goes into 7, 7, and 28. And then what's the number for, what number goes into all 3 of those? Just 7. 7 goes into 7, 7, and 28. So 7. Now, what about like the x? Remember, you're supposed to, for the letters, for the x's, you're supposed to take the lowest x you see anywhere. Here I see x2. Here I see x1, really. Here I see no x at all. So what's the lowest x? No x at all. They don't all have an x. It's not in common to them. Right? That last one, that 28, says, I don't got any x at all. So so you take no x's to the front, because you're only taking out what they all have, what they have in common. And they don't all have an x. So the lowest x is no x's, right? All right, so what goes on the inside then?
X squared.
7 times what would be x squared? X squared. 7 times what? X. And 7 times 4. We're done. Is that good? It's the same game, just 3 of them. All right. Okay, so 7x to the 5th, y to the 3rd, plus 14x cubed, y squared, plus 14xy. So same game, big old parenthesis, something in the front, 3 things on the inside. So you can figure out what goes into 7, 14, and 14. So what goes into 7, 14, and 14? 7 does, right? That's the biggest number that goes into those, right? It's not, you might say, well, it's 14. No, but 14 doesn't go into 7, right? You want the biggest number that goes into all those. 7 goes into all those. All right, now what do you do for the x's? Look at the 3 x's and take the lowest one. And then look at the 3 y's and take the lowest y. Yeah, so what's the lowest x among the 3 x's? Just regular x right here, huh? And what's the lowest y among the 3 y's? Just regular y, again, right there. Does that make sense? For letters, you always take the lowest, because that's really the most they have in common. All right, now figure out the inside. Just try whatever works. Yeah. So it's going to be x to the 4th, y to the 2nd, right? Because the 1 powers will add to the 4 and 2 and go back and be 5 and 3. Is that good? Everybody see how I did that? Because remember, powers add, right? So you need 4 and 2. So it'll add the 1 and the 1 and go back and be 5 and 3. Good so far for the first one? What about the second one? What do we need?
2.
We need a 2 in the front. 7 times 2 will go back to be the 14.
X squared.
X squared, so the 2 and the 1 will make 3. And
Y.
regular y, or y to the first, you don't have to put the 1. So the 1 and 1 will add to be 2. And that'll go back and be that one.
No.
See how I'm making it work? I just put there whatever works. And then 7 times
Plus
2,
two.
that's it, huh? It's already got the xy. So, and then that's our answer. Does that make sense? Questions? All right, so 11x to the 9th minus 12x to the 7th plus 5x to the 6th. So look at those three. Do the same thing, big old parenthesis. Something in front, 3 things on the inside. What number goes into 11, 12, and 5? Yeah, just one. No number, in other words. So this one will just do the letters. That makes sense. There's no number that goes in, other than 1. There's no number that goes into those 3 numbers. There's no number they have in common. Right? There's no number that divides into 11, 12, and
Is it x by itself or x cubed?
So just do the x. On this one, they just have x's in common. They don't have any numbers.
You always get the smallest x.
So just do the x. What x are you going to put in the front?
X to the 6.
Yeah, you always put the lowest one, right? What's the lowest x power? 6. So all we put in the front is x to the 6, no numbers. Does that make sense? You see that they don't have any numbers in common? I'll go ahead and finish it from there. Put in the parentheses, whatever works, huh? Whatever will work to go back. So x to the 6th times 11x to the 3rd. We'll go back to that. Good to there. And x to the 6 times 12x to the 1, or just 12x. We'll go back, add to be 7. 6 and 1 allowed to be 7. Is that good? And x to the 6 times plain old 5. No x's at all, huh? Sometimes, by the way, I see a common mistake. Students will go, no, it's just x with nothing. It's just nothing. That's not right, because when you put nothing on an x, what's invisibly really there? It means 1, and then that would add to be 7. It's only supposed to be 6. That's wrong. So it's no x at all, right? Everybody good with that? So that's the right answer. So that's a problem that just had x in common. They didn't have any numbers in common. Good? No questions? Doing a lot of these, but I want you to be really comfortable because this is super important. These will be with us the rest of the course and the next course and the one after that. So, all right, let's try that one. This time we got 4 terms. Doesn't matter. Same game. Big old parenthesis. 4 terms inside. Something in the front. A minus, a plus, a plus. So when you look at those letters, take the lowest x power and the lowest y power. So as you look at these 4, what's the lowest x power?
Cubed.
X to the 3rd, huh? And what's the lowest y power? Also y to the 3rd, huh? Yeah.
I'm confused though. There won't be anything at the end to multiply those with, or to add them.
Yeah, we'll just put a 1. Because anything times 1 is itself.
Oh,
Good observation.
okay.
Is it car or care? Car? Yeah, car. That's a good observation. Yeah, it's going to have to be a 1 at the end there, huh? Yeah. Yeah, we'll get to that. Let's see. Okay, so what's the first one? So I just took the lowest x and the lowest y and put those in the front. And now we put in inside the parentheses whatever works, huh? powers add. So what power do I need on x and what power on y to go back and be x to the 6th, y to the 6th? 3 on both? We good there? What about the next one? x2, y to the first, or just regular y, to go back and add to go back correctly. And then just x, yeah, because the 3 and the 1 will make 4, and you've already got enough y's, so you don't need any y's at all on that one. Right? And the last one, like we were saying, Carr was saying, and I was saying, x cubed y cubed times 1 will go back to x cubed. Is that a cube?
Why is that one?
What's that?
Why is that one?
Yeah, well, let me ask this. Could I, I think the one good way is, what if I put an x here or a y there? We know that's not right, huh? Because those are really 1 powers, and they would add to be 4 and 4, and it's only supposed to go back to 3 and 3. So it can't be an x and a y. Well, okay, could you just put nothing? Just skip it completely. No, because nothing, well, this times, well, whoops, I just erased it. This times nothing is 0.
See what
That wouldn't go back to this. So what do you need to multiply by to go back? Remember, you got to always ask yourself, what will make it go back? 1. Anything times 1. Right? X cubed, y cubed times 1 will go back to become x cubed, y cubed, won't it?
I would have done x to the second power. And
Here?
y to the second power at the front.
Oh, but that's not right, because you got to, they all have x to the 3rd or more in common. You wouldn't have got all the commonness out. So remember, what's in front is supposed to be the GCF. You didn't get the greatest amount in common. You got some of what they had in common, right? But they all have 3 x's. So if you only put 2, you didn't get the greatest amount they have in common. So that's a good question. See why that wouldn't work, right? I mean, that would be some commonness, but that wouldn't be all the commonness.
Not common sense.
We got to get all the commonness. We good? Does that make sense? So we do have to have a 1 back there. X cubed, y cubed times 1 goes back to x cubed, y cubed. Okay, so 4x to the 7 plus 4x to the 6th minus 28x to the 5th plus 32x to the 4th. All right, so 1 big old parenthesis, something in the front, 4 things on the inside. You know the deal. So, all right, so give that a try. Use your calculator if you need to on some of those bigger numbers. Find a number that goes into 4, 4, 28, and 32. Put that in the front, and the lowest power in the front. So what goes into 4, 4, 28, and 32? 4, right? 2 also goes into all those numbers, but we want the greatest number, 4, right? All right, now, what power on x do we put out there?
4.
Yeah, the lowest one, which is x to the 4th, because that's the greatest amount in common. Good so far? Now, we figure out what goes on the inside, and that's whatever works, huh? So 4x to the 4th times what will go back to 4x to the 7th?
X cubed.
X cubed. Powers will add. Good so far?
2x.
And then 4x to the 4th times
2x.
x squared. Powers will add. Is that good? Right? Because if they multiply, if they distributed, powers would add. 4x to the 4th times what will go back to 28x to the 5th? 7 in the front. 4 times 7 be 28.
And
X to the 1 or just x? because the powers will add to go back to 5. And lastly, 4x to the 4th times what to be 32x to the 4th?
8.
Just 8, no x's at all. It's already got enough x's, huh? Just needs the 8. And there we go. Questions? It's getting easier? Seeming comfortable?
Yeah.
All right, real important that you get this out. If you're having trouble, Roberto, will be a great source. Come see me, office hours, be glad. Okay, so, yeah, they got 5.6 x to the 7th plus 4x to the 6th minus 7.2 x squared plus 6.4x. Okay. So let me give you a one thing to help that's kind of tricky. So you look at that 5.6, the 4, the 72, 7.2, I mean, and the 6.4, and you can think, I have no idea, even with a calculator, how can I find, what goes into all those numbers? It's kind of a crazy one. What's that? Remove it? Oh, well, we can't, though, because there's no equal sign. So in other words, yeah, let me, that's a good question, too. Let me address that. Yeah, a lot of times when there's decimals, you can multiply through by 10 or whatever to get rid of the decimals. But you're only allowed to do that if you have an equal sign and you have two sides. You can only multiply by 10 if you do it to both sides of an equal sign. It would actually not be allowed to just multiply these guys by 10 when there's no equal sign. So we can't do that. So here's what'll help. You'll recognize the number if I make one small change. They're being tricky in the way they're presenting it, and here's the trick. They're mixing the format in which they show you the decimals. I mean, it's not intentional, but what am I talking about? See how the decimal is right there? Yeah, between the two numbers, I mean? Between the two numbers, no decimal at all. You need to make that 4 look like the other ones. Then you'll see it. Yeah, make it 4.0. It's the same as 4, but now it looks like the other ones, right? Decimal in the middle of two numbers. Once you do that, then look, 56, and forget about the decimal now. Just think 56, 40, 72, 64, just forget about the decimal. Just think to yourself, or use your calculator. What if I just had the whole numbers? 56, 40, 72, and 6.4. Use your calculator. What would be the biggest number now that would go into all 4 of those numbers? Would it be, I think 4 will go in, but I think 8 will, won't it?
Yeah.
Try 8. Try dividing them all by 8. I think 8 go, yes. 8 does. 8, you use your calculator if you're not sure. 8, yeah, 4 goes in, but 8's the biggest. Remember we always want the GCF, the greatest? Yeah, 8 is the biggest. You see, the trick is I had to make that 4, rewrite it as 4.0. Why? Because that's the format, the look that all the other ones had. They all had like 2 numbers with a decimal in the middle. So give the 4 the same kind of look, and then just think about them like they're whole numbers. 56, 40, 72, 64. Use your calculator. You'll find 8. Now, 8's the GCF, except now we go back to the fact that it's not really 8. We really do have decimals, so it's really 0.8. Yeah. So the GCF is 0.8. That's the number. And then what about the letter stuff? What's the lowest x power?
X.
Yeah, plain old regular x. The last one's a regular x. So the GCF is 0.8x. Does that make sense? How we came up with that? So it's a trick. You had to look at that 4 as 4.0. And then kind of think like whole numbers. So now just use your calculator. Whatever works. 0.8x times what? Right, we're going to have 4 numbers in here. 0.8x times what? We'll go back to 5.6. Well, if you're not sure, let me help. Take 5.6 on your calculator and just divide by the 0.8. It'll tell you. You can just, if you're wondering what multiplies, divide. Divide will tell you what multiplies. Because dividing is the opposite, right? So if you just take 5.6 and you divide it by the 0.8, it'll tell you, what will it tell you? 7? Just straight 7, huh? Plain 7. Not 0.7, plain 7. Is that good? And what power on the x? X to the 6, because the 1 and the 6, right, makes 7. Good. Try the next 3. Next one, just divide 4.0 divided by 0.8. Right, you can always just divide the number by the GCF in the front. Just keep dividing by that GCF in the front. 4.0 divided by 0.8 is what, 5? 5, and then what power on the x? 5th, because the 1 and the 5 make 6. Is that good? See how I'm coming up with these numbers? Guys and gals, everybody see how I'm coming up with those numbers? I'm just dividing by the GCF. Because when you divide, you find what must multiply. Right? Try the next one. Take the 7.2 and divide by the GCF. Divide by the 0.8. What's that, 9? And you need x, yeah, just x, huh? X, the first x, because that'll add to be 2. Good. And last one, probably out of room there, huh? Yeah, 6.4 divided by the 0.8 is 8. And no x's at all. There we go. So you see the decimal one, see how to handle that? Their trickery. Make it 4.0. Use your calculator like whole numbers. You find that it's 8. Make it 0.8x. And then just divide on your calculator every time. You'll find what's needed to multiply when you divide by the GCF. So I just took 5.6 divided by 0.8. 4.0 divided by 0.8, 7.2 divided by 0.8, 6.4 divided by 0.8. Right? I just did my divisions. My 4 divisions. And I found my numbers. You can always do that, by the way, if you're not sure what to multiply. Just divide by the GCF. It'll tell you. Normally that's too much time, and it's quicker just to do it. But if you need to, it's always there. Okay, so 7/6 x to the 6 plus 5/6 x to the 5th plus 1/6 x to the 3rd plus 1/6 x squared. Okay, so how are we going to do this? Well, big old parentheses. What do they all have in common? Number what? Yeah, 1/6. Do you see that? Because they all have a 6 in the denominator, don't they? Yeah. So that's all you need. And well, then some x's. What power of x do I need? What's the lowest power of x you see up there?
2.
X to the 2nd, right? We always take the lowest power on the x, right? Is that good? Now, okay, I got it. That's the GCF. But what goes on the inside, right? We need the 4 things on the inside. 1/6 x squared times what will go back and become 7/6. Just need the 7 and then x to the 4th. Do you see? Because the 7 is over 1. You don't have to write it that way. But that's what a whole number means, huh? It's already in the top. A whole number means over 1. So it will naturally just go back to the top. You don't need to write that over 1 thing, but you need to think it. Does that make sense? And then the next one, what's the next one going to be? 5, right, because that'll go to the top. X to the 3rd, because the powers add. Good. And then the next one, just 1, x to the 1, and you don't really need to show those 1s. Just x is the same thing, right? Because it'll go back to 1/6, x to the 3rd. Because the powers will add there. Is that good? Is that making sense? So if that's bugging you, you don't need the 1 in the front. You don't need the 1 in the power. I mean, just x is right, too. Right? And then the last one, you do need a 1 there. Yeah. Because you can't leave nothing there. That would mean 0. And 1/6 x squared times 0 would be 0, and that's not right. It's supposed to go back to 1/6 x squared. So you do need a 1 there, like we did on that other problem, right? 1/6 x squared times 1 will be 1/6 x squared, right? So There we go. Is that good? So for the fraction, just pull the denominator out, basically. All right, so there are. Okay, so let's take a look. So now, x to the fourth, x plus 3, plus 9x plus 3. Okay, I want to solve this for you by changing the question. I think it'll be easier. Let me just ask you, what if it's like, probably don't have much room over there, let me go down here. It's like x to the fourth, let's say w, plus 9w. Just forget about the main question for a minute, because I know this confuses people a lot. And just think with me, what if somebody gave you x to the fourth w plus 9w? And they want you to factor it, right? They want you to do like the parenthesis thing and something in the front and two things on the inside. What do they both have in common that you would put in the front? What does x to the fourth w and 9w both have? W. They both have a w, don't they? They don't both, I can't take any x's out because the second one doesn't have x to any power at all. So they don't both have x in common. They don't both have any front numbers in common because the first one has no front numbers. All they have in common is w, right? So I would put the w in the front, and I would go, okay, w times what? We'll go back to x to the fourth w. Well, x to the fourth. There's nothing else there. And w times what? We'll go back to 9w. Well, 9. Is that good? Now, that would be all you would need to do for that problem. Ours is like it, but I want to make sure you're good with this first. That makes sense. So if you have two, remember what we're doing? We're pulling out the commonness. Whatever they both have, right? It's like if I went around the room and I said, hey, you've all got a pencil, I'm taking it, right? I'm taking what they all have. I'm taking whatever's in common. So I'm looking at the x to the fourth w and the 9 and say, hey, what do you guys both have in common? Well, we both got a w to the front. Whatever they both have. And then, how do you know what's left on the inside? Well, whatever would multiply to go back. Whatever would multiply to go back. Is that making sense? I would remove it. So it's kind of like you cross off the w when you take the common part and the other part drops down. That's another way to think of it. Does that make sense? Right? If I went around the room and took all your pencils, what would be left is just you without your pencils, right? That's kind of like what happens here. When you go to the x to the fourth w and the 9w, you take the w's from both of them. So what's left is the x to the fourth and the 9. They don't have their w's anymore. Make sense? So what if I gave you x to the fourth b plus 9b? And you wanted to factor. What would you put in the front? What do they both have in common? B. Remove what, take it out of their hands, bring them down without their b's anymore. Done. Right? Because if you multiplied that, it would go back, wouldn't it? So you see how we're just always taking whatever they have in common, put it in the front, and then bring them down without that common piece anymore. Is that making sense? Well, that's exactly what this question is up here. It's just a big, fancy version of it. But you want to see the pattern. Math is the science of patterns. Do you see the pattern is the same? It's just bigger. This is like my W or my B. What does this guy and this guy both have in common? A big old parenthesis x plus 3. It's just like having a B in common or a W in common. What do? Same thing we did down there. You do one big parenthesis, and you say, I'm going to take out of their hands that common thing they both have. It'd be like if I went around the room and took all your calculators. Hey, you've all got a calculator instead of your pencil. I'm just taking a bigger thing. It's still what they have in common, right? So I'm going to take the x plus 3, take the x plus 3, and I put it in the front. Does that make sense? Now, a lot of times students will ask me a good question. They'll say, now, Mr. Aaron, there's two of them. That should be squared. No. That's follow the pattern. That's never what I did down here. I didn't make this b squared, did I? There were two b's, but I always just put one of them in the front, huh? Because that one could distribute and go back to both. We only put one in the front. That's what we've always done. That's the pattern.
We're still keeping their parentheses.
Right. In this case, it has its own little set of parentheses. Good observation. Yeah, that's what's weird and what throws people off a lot. is those extra parentheses, huh? Yeah, but you're totally right. It's got its own little personal set of parentheses, the x plus 3 does. So I take it out with its own little personal set of parentheses. But there's another set for the leftovers to go in. And what's left over? X to the 4th and 9. And that's our answer. Why? Because that whole parenthesis x plus 3 could go back, and we'd be back where we started. It's right. Does that make sense? So you just take out what they both have. So here, let me show one more time. And, maybe too many analogies can be overkill. So let me just show you just this one more time. So, let me say this one thing I think that'll be helpful. This plus outside parentheses is the separator. You want to look at it like that. I think that's important for how you want to look. There's so much mess in these things. That's how you want to look at it. So one more time on that. Pluses and minuses outside of parentheses are the separators. Those are the separators. How about this? You guys ever deal with horses? You guys ever deal with horses? That's right, you've dealt with horses. Huh? We've talked about that. I've dealt with horses. I just love horses. No, I don't love horses. But I've got daughters that love horses, and so, against my will, I've dealt a lot with horses. Anyway, and I've paid a lot of money for horses, is what I've done. And horses are very expensive. They're expensive buying, they're expensive keeping, and then you even pay when they die. You pay come and go in between and every which way. Hauling them. Anyway, enough with my financial woes about horses. Anyway, one time, one of my daughters, Lizzie, handed me the horse. We were out somewhere, and she handed me the horse, and said, the rope holding the horse. I've never been on a horse. I've never been on a horse. Anyway, my daughters are all into all this jumping and stuff. Anyway, I held the rope for the horse. She had to go do something, right? Well, the crazy beast, it pulled its head, and the rope flips out of my hand. It was 1,000 pounds. I'm not going to fight with a horse. It pulls the rope out of my hands, and then then the gate was open. So it just went out the gate and took off. Lizzie came running back. You let the horse go? And I'm like, well, it pulled the rope out of my hands. I don't know what to do with that crazy animal. It got outside the corral, and it went. And that was a bad thing. And we had to go chase it down, and it was a problem. So all that is to say, pluses are like loose horses. You don't want them outside of parentheses. That's a big deal. So I'm telling the whole story. That's a big deal. I'm going to come back to this 1,000 times throughout this course. Pluses and minuses, loose, not corralled, outside the parentheses are a big deal. They're the separators, and they mean you're not done with the problem. In the end, that's how we'll know when we're done, when all the horses are corralled. When all the pluses and minuses are contained, we're done. That's how you know. So think of that, so that's going to really matter. All right, so that's how you look at it. You go, okay, I got this guy and this guy. There's the separator. So what do this guy, whoops, I'm erasing. This guy and this guy both have in common? What do they both have? A parenthesis, x plus 3. Don't they both got one of those? Okay, remove it. Just start a new set of parentheses. Drop down the leftovers. Look, all the horses are contained. All the pluses are corralled. Done. That's how you know you're done. Make sense? All right, let's go to some more horses. I've had all kinds of, we've had 2 horses with eye problems. I can tell you my horse woes. Horse flipped itself over backwards and went blind. An expensive jumping horse. Then I paid for a year of treatments trying to get it to see again. And then I paid to put it down. You pay and pay and pay, and then you pay. All right, so anyway, there's my problems. So, all right, so try that one. And how you want to look at it, remember what separates things. Pluses and minuses outside. So there's the 2 terms, there's the separator, right? Pluses and minuses outside of parentheses. That's the separator. That's how you want to visualize it. That's how you want to look at it. So what do they both have in common? Parentheses 8a plus 9, right? They both got one of those. So what do we always do? We put the common piece in the front. Remove it. Start a new set of parentheses. Drop down the leftovers. That making sense? So bring down the leftovers. 4a to the 5th minus 7. Done. Is that making sense? You take the common piece to the front, remove it, new set of parentheses, drop down the leftovers. All the horses corralled. All the pluses and minuses contained, you know you're done. When they're contained.
Why wouldn't we multiply it when parentheses are together?
If we multiply this out, it would go back.
That's right.
Yeah, we are unmultiplying. You're exactly right. Now, I'm glad you brought that up. It's a good point. That's exactly what we're doing, is we're saying, what would it be that would multiply? That's right. Yeah, we just did a whole section on multiplying, I know. It's like we're going back and forth. That's exactly what we're doing, yeah. Here. Okay, x cubed plus 6x squared plus 7x plus 42. 4 terms. All right. This is going to be different. What do they all have in common? That's always the first question, right? What do they all have in common? All 4 of them. Nothing. Do you see that? Let me write that. Nothing, right? Because they don't all have an x. The 42 doesn't have an x. There's no number they all have because the front one, the x cubed, doesn't have any number at all. Nothing in common to all 4. So, what do you do when there's nothing in common? I cannot do one big parenthesis. I can't do it. There's nothing they all 4 have. I can't pull anything in common from all 4 because they all 4 don't have anything in common. You cannot do one big parenthesis. So instead, 2 terms, 2 terms. It's called grouping. You split them up. You make them into 2 groups. So this is a special in our last deal. You do 2 terms separately because there's nothing in common to all 4. Everybody see that? All right, so what do just the first 2 terms, just the first 2, what do they have in common? Yeah, you're right. Imagine the problem is just the first 2. Forget about the back 2 completely. Just pretend the whole problem is just x cubed plus 6x squared. Just the first 2. What would you do if you just had those 2? What do they have in common, just those 2? X squared, right? Just those 2. And what would go on the inside? X squared times what will go back? X, and x squared times what will go back? Plus 6. We good? Good so far? Now, in the middle of the groups, very important, very, very important. These horses that are loose are very important. That plus sign, he's got to be there. Lots of times students will just kind of skip him. He's really important. Now do the back 2. Pretend the whole problem is the back 2 and nothing else. What do they have in common? 7 goes into 7 goes into 42, you remember. And then what goes into 7 times what? X. And 7 times what? You see how these match? They will always match. You can predict it. You can see it coming. Okay, now, can I stop there? Can I go, I did it. I'm done. If you heard my horse story, or if you're thinking, maybe you heard it, but if you're thinking about my horse story, you'll know the answer is no. He's running loose. You're not done. Uncorralled horse, right? So you're not done. And that tells you you're not done, and it tells you how to look at it. That's the separator, right? So that tells you boom and boom. Right? That tells you you're not done, and here's how to visualize it. 2 terms, and what do they both have in common, those big terms now? What do they both have the same? The x plus 6 parenthesis. Remove it. Start a new set of parentheses. Drop down the leftovers. X squared plus 7. Am I done now? All the horses are contained. Done. That makes sense. So that was longer. That was 2-step, not just a 1-step. Why do we have to do all that? Carr wants to be an engineer, and he's got to learn how to do this. Helicopter pilot. So all 4 terms had nothing in common. Did everybody see what drove that vehicle? What made that go? What was the gasoline? The fact that all 4 had nothing in common. It's the first time we've experienced that, right? Hold on, no putting away all your stuff now. We have 7 golden minutes, and I want to use every one of them for your benefit. Hang in there. So everybody getting the point there. 4 terms that had nothing in common. So I did a 2-2 split, right? All right, try that one. 35x cubed minus 63x squared plus 20x minus 36. All right, first question. Do they all four have something in common? Is there like a number that goes into all those? You can use your calculator. No is the answer. 5 doesn't go into all of them. 7 doesn't go into all of them. 2 doesn't go into all of them. No.
The 7 is.
And do they all have an X? No. The back one, 36, he's got no X. So there's nothing in common to all four. So what does that mean when we see nothing in common to all four? 2-2 split, called grouping. You make two separate groups out of it because you can't do all four together, right? There's nothing in common to all four. So you got to do a 2-2 split. First two, last
7x squared.
So first two, last two. So just do the first two as if they're the whole problem.
What?
Okay, so what goes into 35 and 63? Use your calculator. 7, right? Don't they both divide by 7? 7. Yeah, and then you look at those two, what powers, what's the lower of the two powers? X squared. You always take the lower power, right? So 7x squared goes in front of the first two, and then use your calculator to find out what goes inside to make it work. Right? 7x squared times what? We'll go back to 35x cubed. 5x. We good there? And 7x squared times what? We'll go back to 63. Negative 9. Good for those first two. That making sense? Now, remember that sign in the middle, super important, that loose horse, because that's going to tell us we're not done. We have another step. Don't skip him. All right, now back to 20 and 36. What goes into both those numbers? 4. 2 goes in, but 4 is the greatest number that goes in. And greatest amount they have in common. Now, do they both have an X? No. So just going to put parentheses. Guess what's going to be in those parentheses?
5x minus 9.
Yeah, the same as the other one. Remember how they always match? Just go ahead and write it in. You can double check if you want to. 4 times 5, 20, yep. 4 times 9, 36, yep. It's a good double check. They've got to match. They will make them match. That good to there? Does that make sense how I did the first two and the last two?
Yeah.
Now, can I stop here?
No, yeah, the horse.
Got the loose horse. Not a good thing. Right? So that tells us we've got to keep going. It tells us how to go forward, how to look at it. Right? It's the separator. So what do they both have?
5x minus 9.
5x minus 9. Remove it, remove it. Start a new set of parentheses. Drop down the leftovers. Done. All horses contained. Good. See how I put the parentheses in the front? Remove it. Bring a new set of parentheses and drop down the leftovers. Okay. 8x cubed minus 8x squared. This one's going to have a little trick. Let you see if you can see it. What that trick is. So first off, is there something in common to all four terms? Do they all have an x? No, that 1 doesn't have an x. Do they all have a number? No, that 1's just 1. So nothing in common to all four. So what does that always mean we do when there's nothing in common to all four? 2-2 split, called grouping, 2 groups. First 2, last 2, right? Okay, now, what do the first 2 have in common?
8x squared.
What do those first 2 have? Yeah. 8, right? And what power do we put? The lower power, right? X squared. Everybody good with that? For the first 2? You always put the lower power, right? X2 is lower than X3. Okay, then figure out what works on the inside there. 8x squared times what? We'll go back to 8x cubed. X. And 8x squared times what? We'll go back to minus 8x squared. Minus 1. We good so far? Now, remember that sign in the middle, that loose horse, real important. Bring that down. Now, here's the new part. Here's the part I wanted to show you. It won't take long, but I just want to make sure you see it, because it'll come up. It'll be on the test. It'll be in your homework. It'll be in the future of the course. Those back 2 have nothing in common. Right? X and 1. They got nothing, right? They don't both have an X. They don't both have a number. They got nothing in common. What do you do when the back 2 have nothing in common? You just put a 1, because you got to have something. 1 goes into every number, right? 1 goes into everything.
Couldn't you just leave the negative because you're gonna?
It'll help. I know what you're saying. This will help. This will help. Technically, yes, but this will be helpful. So put the 1. So put a 1. 1 goes into every number. Now, what's going to go in those parentheses? Any guesses?
X minus 1.
Yeah, it's going to be the same as the other one. Now, is that really right, though? Let's double check. Minus 1 times x, minus x. Minus 1 times minus 1? Sure enough, beautiful. Plus 1. It's exactly right, isn't it? Yeah. Now, can we stop here?
No, you have the horse.
Got the loose horse right here. So we're not done. One more step. Right? What do they both have in common?
X minus 1.
Parenthesis x minus 1. Remove it. Start a new set of parentheses. Drop down the leftover. 8x squared. That's why I put the minus 1. Because now I got something to put back there. There we go. All right. You've seen it all. It's clicking A for apple. A for apple for